Good evening, students.
Sir,
Good evening, sir.
So, yesterday we have discussed about the PKA and PKB, conjugate acid base, everything we discussed. Today, we are going to see, so this is the relationship between PKA and PKB. Now, we are going to see so we are going to see about the polybasic acids. So acid means it has to give the H plus ion. If it is contain more than one H plus ion, then it is called a polybasic acid. So when you have the polybasic acid, if you are taking HCl, it's a monoprotic acid. If you are taking H2SO4, it is a diprotic acid. And if you are taking H3PO4, it's a triprotic acid or polyprotic acid. Or H4P2, O7 pyrophosphoric acid. These are the polybasic acid. Okay. So this type of acid, if you are taking, it undergo ionization in how many number of proton it has, that much number it will take to complete the ionization. So if you are taken orthophosphoric acid, orthophosphoric is nothing but H3PO4. That means P double bond O, OH, OH, OH. This is the shape of the polyphosphoric acid. When it undergo ionization, it gives H plus plus H2PO4 minus. This H2PO4 minus will undergo further ionization, that will be K2. It gives H plus plus HPO4 2 minus. This HPO4 2 minus undergo ionization, it gives H plus and PO4 3 minus. Now you have K1, you have K1, you have K2, and you have K3. You have K3. So which will have the higher value? When you have this K1, which is have more value than K2, which in turns more than K3. So if you want to calculate overall dissociation constant. So the overall dissociation constant K become K1 into K2 into K3. So this value is very less when compared to K1. And then we can see factor affecting the acid. So if I take an H, hydrogen chloride, hydrogen bromide, hydrogen iodide, all have H plus ion common. So here F minus, here Cl minus, here Br minus, here I minus ions. So among the four, which is the strong acid? Which is the strong acid?
HCl, sir.
HCl, sir.
H
Cl.
HCl, sir.
HCl is a strong acid.
Yes, sir.
Is it so? No. HI is the strong acid, then HBr, which it turns more than HCl, which it turns more than HF. What is the reason? So there are two factors which decide the acid strength. One is bond strength, and another one is bond polarity. So in chemical bond, we have studied about the Fajans rule. What is Fajans rule? And dipole moment. Do you remember these two? These are the two factors. It says when the covalent compound having some ionic character by meaning of dipole moment. When the ionic compound have some covalent character, by it was explained by the Fajans. So these are the two rules which say no compound is 100% ionic, no compound is 100% covalent. It has some covalent character and also that I have some ionic character. This is what you can explain from this factor. Now, there are two factors which affect the acid strength. One is the bond strength, another one is the bond polarity. So what bond strength will do? So when we are saying it's a strong acid, if it is readily give the H plus ion, it is a acid. Am I right? So the strength of the bond between the proton and the rest of the molecule will have an effect on acid strength. Weaker the bond, stronger the acid. So weaker bond, weaker the bond, stronger the acid. So how we are saying you take H and F, H and Br, sorry, H and Cl, H and Br, H and I. This is 1s, it has 2s 2p, it has 3s 3p, it has 4s 4p. That means bromine, chlorine, and iodine 5s 5p. So the 1s orbital overlapping with the 2s 2p orbital. This 1s orbital overlapping 3s, 4s 4p, 5s 5p. So when you are seeing the effect of overlap will be more for this because this will be the smaller the size of ion. When compared to all those things, it will be a smaller size. So when it overlap, the overlap will be effect. So the bond will be strong. So bond is strong when compared to hydrogen iodide. Here it is weak because smaller 1s orbital, the higher 2s and 2p, 5s and 5p orbital. So now the overlapping, effective overlapping will be less, so it will be the weaker bond. So when it weaker, it can readily release the H plus ion easily. That's why it's a strong acid. So bond strength is inversely proportional to acid character. Okay, and then bond polarity. So bond polarity. So polarity means the distribution of electron between the two bonded atoms. So electron will go, which is having more electronegative element. So when you have A and B, which is having more electronegative, that side the pair of electron will go. So because of that, what will happen? A will bear a positive charge, B will bear a negative charge. So the polarity will be taken place. So if the atom, the electron distribution is unsymmetrical between the atom, means there will be a polarity. We know that when you have the smaller size of the cation and larger the size of anion, there will be a polarity. That's what will be said by the Fajans. Okay. So the acid character will be more when you have smaller size cation, larger size anion. So what happened? So the small size proton, the cation will have the affinity with this. So the bond polarity. So highly polar bond. So bond is polar, then automatically the acidity will be more. So among the four, the polarity will be more for the hydrogen. That's why it is a stronger acid. Okay. So this is what these are the two factors which affect the acid strength. And then another important factor we are going to discuss is common ion effect. Have you come across anywhere? Common ion effect. Have you come across? நீங்க பாத்திருக்கீங்களா காமன் அயன் எஃபெக்ட்? Have you come across or not? Okay. So the common ion effect is nothing but when the substances are in the equilibrium. Okay. So if you are adding any common ion in that equilibrium, for example, you have AB salt you are taken, that AB salt in the equilibrium, A plus ion and B minus ion. Additionally, you are adding A plus or B minus containing some salt. இப்போ வந்து அம்மோனியம் அசிட்டிக் ஆசிட் எடுத்துக்கிறீங்க. Okay, you are taken acetic acid, it's a weak electrolyte. When it dissociate, it will give acetate ion and H plus ion. Now you are adding sodium acetate, it's a strong base. So when you put it into the water, it becomes CH3COO minus and Na plus. Now in the solution, you have acetate ion will be more. Okay. Now this one, if you are adding here, now what will happen? You have the forward reaction and backward reaction. So the equilibrium is disturbed. So when you are adding a common ion to the weak electrolyte, so the weak electrolyte establishing its equilibrium with its own ion. When you are adding a common ion to that equilibrium mixture, then the equilibrium is suppressed. Either forward reaction will suppress or backward reaction will suppress. Now, look here. You have the acetic acid. It gives acetate ion and H plus ion. It's a forward reaction. Now, the acetate ion and H plus ion will combine. It gives the acetic acid. It will be the backward reaction. Now, if you are adding concentration of CH3COO minus to this, so what will happen? As the concentration of CH3COO increases, means forward reaction will take place. அதாவது reactant increase ஆனா product form ஆகும். இப்போ இதுல இதான் reaction. CH3COO minus concentration increase பண்ணா, so it undergo backward reaction. It gives more CH3COOH. So due to that, this reaction, அதாவது forward reaction is suppressed. So this is called common ion effect. So how can we define this? If it is stated that if to the solution of weak electrolyte, either in the acid or in the base, a solution of strong electrolyte is added, which furnish an ion common to that. So, furnished by the weak electrolyte, the ionization of weak electrolyte is suppressed. Is it clear? So, suppression of, otherwise we can say suppression of ionization of a weak electrolyte. Weak electrolyte, it may be acid or base, by adding one of its own ion, is known as common ion effect. So lab பண்றீங்களா ஸ்கூல்ல? Have you done salt group separation, cation analysis பண்றீங்களாம்மா?
Yes, sir.
Group separation பண்றீங்களா?
Sir,
ஸ்கூல்ல பிராக்டிகல்ல இந்த கேட்டையன் அயனியன் அனாலிசிஸ் பண்றீங்களா?
yes, sir, salt analysis.
Salt analysis பண்றீங்க. Salt analysis பண்ணும்போது first group metal, second group metal, third group metal, fourth group metal பண்றீங்களா?
Yes, sir.
இப்ப அங்க என்ன பண்றீங்க? You are separating. ஓகேவா? Now first என்ன பண்ணுவ? You will prepare your original solution. So you will prepare your original solution. To the original solution, you will add dilute HCl. So if the precipitate comes, it's a first group. Precipitate comes means it's a first group metal. Suppose if it is not coming means what you will do? So to that solution, you will add dilute HCl plus H2S. Then any precipitate is coming, it because of second group. Correct? So first,
Yes,
second, and third, what will do? You will heat the solution. So you will boil off the H2S. நல்லா ஹீட் பண்ணும்போது H2S gas வெளியே போயிடும். Then you will add ammonium hydroxide and then ammonium chloride. If you are having gelatinous precipitates, it become third group. Correct? If you are not getting, you will move further. What you will do? The next, you will add ammonium hydroxide and more H2S gas you will pass. If you are getting precipitate, it because of fourth group metal. And then if you are not getting, you will heat the solution and you will add ammonium hydroxide plus ammonium chloride plus ammonium carbonate. If you are getting precipitate, it becomes fifth group. So this is how you are doing that. Look here. Here, what is the group reagent for the first group? Dilute HCl. Second group, dilute HCl and H2S. Third group, ammonium hydroxide, ammonium chloride. Fourth group, ammonium hydroxide, H2S. Fifth group, ammonium hydroxide, ammonium chloride, ammonium carbonate. In the first group, it will precipitate as metal chlorides. It will precipitate as metal chloride precipitate. It will precipitate as metal sulfide precipitate. It will precipitate as metal hydroxide. M2S or MS. It will precipitate as MS, metal sulfide. It will precipitate as metal carbonate. So here sulfide as precipitated, hydroxide precipitated, sulfide precipitated, carbonate precipitated. Now here and here you have both sulfide. Correct? Second and fourth group பாருங்க. இதுலயும் H2S gas தான், இதுல H2. What is the difference between these two? What is the difference between these two? What is the difference between these two, ma? The second fourth என்ன வித்தியாசம்? What is the difference between second and fourth? By seeing the equation, you can tell. Hariharan, you just change me as a host. Now you tell me what is the difference between second and fourth? இப்ப பாக்குறீங்களா, பார்த்து கூட சொல்ல முடியாதா? The common will be H2S. What is the difference between these two?
Sir,
Here second group you have ammonium, fourth group ammonium hydroxide. So look here. So here also it precipitated as a sulfate. Here also it precipitated as sulfate. Then what is the difference? Yes, we have some difference. Okay, that we will do it now.
Sir, acid and base.
Inama? Yes.
Acid and base.
Kelma? Acid
And base.
and base. Very good. So one thing you are having in the acid medium, another thing you are having in the basic medium. So in that, what will happen? So now I will explain the common ion effect. So when you are taking H2S, it's a weak acid. It's a weak acid. It dissociates into H plus 2H plus ion and S2 minus ion. It will dissociate into H plus ion and 2H2 S2 minus ion. When you are adding HCl. Okay, so HCl is a strong electrolyte. When you put it in the water, it becomes H plus and Cl minus. So this is the equation 1. This is the equation 2. When you are adding addition of HCl to the first one to H2S, what will happen? H2S suppression will be, so that means this is the forward reaction, this is the backward reaction. When we are adding H plus ion, here the H plus ion concentration will be more, so that the backward reaction will take place. It suppress the forward reaction. So what will happen? So when adding H2S, forward reaction suppressed. Forward reaction is suppressed. So due to that, you have very less concentration of S2 minus. This concentration is enough to precipitate the second group metal. So what are the second group metal? Copper, mercury, lead, silver. So these are the metal you can separate by using the H2S in HCl. In case I am adding ammonium hydroxide, what will happen? So the ammonium hydroxide, if you are adding, it will dissociate into NH4 plus and OH minus. Correct? So this is also weak, but when you are adding this, you have the OH minus ion, this OH minus ion, so addition of NH4OH to H2S, this OH minus ion will take H plus ion, so H2S, it gives 2H plus ion plus OH minus ion, sorry, S2 minus ion. This H plus will take the OH minus and it form a water. Now what will happen? The backward reaction is suppressed. Backward reaction is suppressed due to addition of ammonium hydroxide. It will form a water. That is the reason why the dissociation of H2S become more. So you have more concentration of S2 minus. So this S2 minus is sufficient to precipitate the fourth group metal. Ella fourth group metal, copper, nickel, manganese, and zinc. These are the four metal which can precipitate zinc. Now you may ask, sir, what is the advantage of this? When you take the metal brass, brassல என்னென்னப்பா இருக்கும் அந்த அலாயில? brass அலாயில என்னென்ன இருக்கும்? என்னென்னலாம் இருக்கும்?
Sir, copper and zinc, sir.
Zinc. Sir, okay. Copper and zinc. Now, I want to estimate the percentage of zinc present in the brass, and also I want to express, I want to know the percentage of copper present in the brass. So what they will do now, if you have the mixture like this, it will give the sulfate, copper sulfate and zinc sulfate, it will give. Whereas here you can use, when you put it in the concentrated HCl, you are changing the medium. Okay, now you have the solution of copper zinc in concentrated HCl. Now if you are passing H2S, the S2 minus quantity, the sulfur S2 minus is very less, so it will precipitate only the copper sulfate. So it will precipitate copper sulfate, leaving is that in the solution. Why? Because when you are adding HCl, it suppresses the forward reaction. So you have the very less quantity of S2 minus. This quantity is sufficient to precipitate the second group metal, then the fourth group metal. So in the solution Zn இருக்கும். Zn எடுத்து நீ வால்யூமெட்ரிக்கா எஸ்டிமேட் பண்ணாலும் சரி, இல்ல வந்துட்டு அது கூட அதை ஏதாவது காம்ப்ளெக்ஸா மாத்தி, so you can make it as complex. From the complex you can calculate zinc. Then you change it to copper sulfate. No, this you can estimate, it give the percentage of copper. So these are the application of common ion effect. So ஒரு common ion effect போடும்போது same H2S two different typesல வந்து dissociate ஆகுது. So இதுதான் என்ன சொல்றோம், when you are at suppression of ionization of weak electrolyte, the electrolyte may be acid or base, the equilibrium. So this is known as common ion effect. So where it will be useful, purification of common salt by passing HCl gas into saturated solution of NaCl, and soap is precipitated by adding NaCl. These are the place by which you can separate common ion effect. இன்னொரு இடத்துல என்னன்னா, third groupல பாருங்க, ammonium hydroxide, it dissociate into NH4 plus ion and OH minus ion. If you are adding ammonium chloride to this third group, adane ammonium chloride என்ன ஆகும், NH4 plus Cl minus ஆகும். Suppose if you are adding there to this, means the concentration of ammonium will be more. So you tell me, forward reaction வந்து suppress ஆகுமா, backward reaction suppress ஆகுமா? which will suppress more? Forward or backward? If you are increasing the concentration of ammonium, so the forward will suppress or backward will suppress. எது suppress ஆகும்? எதுமா suppress ஆகும்?
Sir, forwards.
Very good. Forward. Because the NH4 concentration more போது backward reaction தான் நமக்கு நடக்கும். So எந்த பக்கம் concentration அதிகமா இருக்கோ அதுக்கு opposite directionல தான் reaction நடக்கும். So இங்க concentration ஜாஸ்தியா இருக்கிறதுனால இதுக்கு opposite என்னது backward reaction தான். இப்படி வந்தேன்னா forward, இப்படி போனா backward. So this reaction is taking place. Very good, very good. So now you have the very less quantity of OH minus that is sufficient to precipitate the third group metal. So these are the application of your common ion effect. Now the next important one is buffer solution. So what is the meaning of buffer? Computer la buffer பண்றோம் buffer அப்படின்னு சொல்ல what it mean? What it mean? What is the meaning of buffer? So buffer na enna?
Neutral, sir. Neutral, sir.
Neutral ஆ இருக்குது இல்லையா?
Sir.
So இப்போ நம்ம ஒரு reaction பண்ணிட்டு இருக்கோம். So we want to maintain the pH same ஆ இருக்கணும். So அப்ப என்ன பண்ணணும்னா we have to something to maintain the pH same. அதுக்காக ஒரு solution add பண்ணுவாங்க. அந்த solution பேர் தான் buffer solution. ஓகேவா? So the buffer solution is defined as the solution which resists the change in the hydrogen ion concentration and adding small amount of acid or base is known as buffer solution. That solution is known as buffer solution. So solution which resists the change in the concentration of H plus ion on the addition of small amount of acid or base is known as buffer solution. Okay, now this buffer solution can be two types. One will be acidic buffer, another one will be basic buffer. So acidic buffer is equimolar quantity of weak acid plus strong base. For example, acetic acid plus sodium acetate. Same way, formic acid plus sodium formate. Okay, so same way, basic buffer is it's a equimolar of weak base plus strong acid. Example, ammonium hydroxide is a weak base, whereas ammonium chloride is a, compared to ammonium hydroxide, ammonium chloride is a strong base, strong acid. நீங்க உடனே HCl எல்லாம் கேட்டுறாதீங்க. No. Then aniline plus anilinium chloride. So these are the called as buffer. So what is the application of buffer? So the ability of the buffer to resist the change in pH value on addition of small amount of acid or base or strong base is called buffer action. So the pH of buffer solution can be calculated by means of Henderson equation. So the Henderson equation used to calculate pH of buffer solution. So how you can calculate? So we'll work it out this one. When you take a weak acid, so I will call it as HA. When you are put it into the water, what will happen? It will become H3O plus A minus. Since it gives the acid, it dissociates like that. So if the acid dissociation constant Ka become the product of H3O plus into A minus by HA. So please remember H3O plus is equal to concentration of H plus. ஏன்னா நீ வெறும்னே HA ன்னு எழுதுன்னு வச்சுக்கோ, HA which will hydrolyze H plus and then A minus இப்படிதான் இருக்கும். So இதுக்கு Ka எழுதுனா என்ன வரும்? Ka is equal to H plus into A minus divided by HA. இப்படிதான் எழுதுவேன். இப்படி எழுதினாலும் சரி, அப்படி எழுதினாலும் சரி, ரெண்டும் ஒண்ணுதான். Now we need a H plus ion. So H plus ion இங்க வச்சிட்டு Ka into HA divided by A minus. So take minus log on both sides. So எடுத்தா என்ன வரும்? Minus log H plus log of Ka into HA divided by A minus. So log A by B is equal to log A by B is equal to log A minus log B. Log AB is equal to log A plus log B. So this is the rule. Now you tell me these two are in the first, we'll separate. So is equal to so minus log minus log Ka minus log HA plus log A minus. So அது விரிச்சு எழுதணும். We know that minus log H plus become the pH. அப்ப minus log Ka become the pKa. So இப்ப என்ன பண்ணலாம்? Minus log of A minus divided by HA. HAங்கிறது என்னது? acid. A minusங்கிறது என்னது? salt. So pKa minus so இப்போ மைனஸ் லாக் இருக்கு, லாக் ஏ மேல இருக்கு, HA கீழே இருக்கு, அதனால லாக் ஆஃப். ஸோ இது எப்படி எழுதலாம்? லாக் A by B அப்படின்னு எழுதலாம் இல்லையா, அந்த மெத்தட்ல. ஸோ பிளஸ் லாக் A minusங்கிறது salt, HAங்கிறது acid. So pH equal to pKa plus log concentration of salt divided by concentration of acid. So this will be, so if you are working out for the base ஒரு example எடுத்துக்கலாம், ammonium hydroxide. So ammonium hydroxide எடுத்தோம்னா it dissociate into NH4 plus ion plus OH minus ion. So when you are dissociating, Kb value become NH4 plus concentration and OH minus ion concentration, that divided by ammonium hydroxide. So the OH minus ion concentration for the base, it become Kb into NH4OH divided by NH4 plus. So taking log on both sides, minus log OH minus, that's equal to minus log Kb minus log of NH4OH concentration divided by NH4 plus. So this become POH, this become PKB. So இப்போ என்ன பண்றோம், உல்டா பண்றோம், plus log NH4 plus divided by NH4OH. So NH4 plusங்கிறது என்னது, salt, PKB plus log salt by base. Salt oda concentration divided by base oda concentration, அதோட log, it gives POH. We know that pH plus POH is equal to 14. So that pH is equal to 14 minus POH give the pH of your basic solution. So this is the Henderson equation. This equation and this equation will be the Henderson equation. From this you can calculate any solution pH value. Okay. So இதே போல நீங்க salt எல்லாத்தையுமே ஹைட்ரலைஸ் பண்ணீங்கன்னா எல்லா விதமான சால்ட்டுக்கும் நம்மளால இது கண்டுபிடிக்க முடியும். So what are the types of salt? So when you are taking salt hydrolysis, general statement. So what are the salt having? Strong acid and strong base. For example, NaCl, KCl, KNO3, Na2SO4, KClO4 இந்த மாதிரியான சால்ட் இருந்ததுன்னா அதோட pH வந்து 7 இருக்கும். நியூட்ரலைஸ் ஆச்சுன்னா அதே ஆசிட் வந்து ஸ்ட்ராங் ஆசிட் எடுத்துக்கிறீங்க, ஸ்ட்ராங் பேஸ் ரியாக்ட் பண்றீங்க, சாரி வீக் பேஸ், ஃபர்ஸ்ட் ஸ்ட்ராங் பேஸ் அடுத்து வீக் பேஸ் பண்ணும்போது என்னென்னு பாத்தீங்கன்னா அமோனியம் குளோரைட், காப்பர் சல்ஃபேட், அமோனியம் நைட்ரேட், அலுமினியம் குளோரைட். இதோட pH பாத்தீங்கன்னா pH will be less than 7. So இது எப்படி கண்டுபிடிக்கணும்னு பாத்தீங்கன்னா pH equal to 7 minus 1/2 pKb minus log C. C is the concentration of salt. So by using you can find out. And the next one is weak acid, strong base. So example, Na2CO3, KCN and sodium acetate and potassium carbonate. So இதோட pH definitely greater than 7 தான் இருக்கு போகுது, ஏன்னா strong base யூஸ் பண்றோம்ல அதனால. So அப்ப அதோட pH எப்படி கண்டுபிடிக்குது? So the pH equal to 7 plus half of pKb, so pKa plus 1/2 log C. அதே போல ஈக்குவேஷன் டெரைவ் பண்ணோம்னா நமக்கு வரக்கூடியதுதான் கடைசியா போட்டிருக்கு. நெக்ஸ்ட் weak acid and weak base. weak acid and weak base என்ன எக்ஸாம்பிள் பாத்தீங்கன்னா ammonium carbonate, ammonium acetate, aluminum phosphate இதெல்லாம். ஸோ இதோட pH எப்படி இருக்கும்னு பார்த்தீங்கன்னா pH equal to 7 plus 1/2 pKa minus 1/2 pKb இருக்கலாம். அப்படி இல்லைன்னா pH equal to minus 1/2 log Ka plus log Kw minus log Kb. ஸோ இந்த மாதிரி தான் அதோடைய ஈக்குவேஷன்ஸ் இருக்கும். ஸோ பெரும்பாலும் நீங்க இந்த ஈக்குவேஷன் ஞாபகம் வச்சுக்க போதும். இது சால்ட் ஹைட்ராலிசிஸ். ஓகே, ஸோ நெக்ஸ்ட் ஒன் இது முடிஞ்சா இந்த ஓவர் என்ன ப்ராப்ளம் சால்வ் பண்ணலாம் இல்ல அடுத்த லெசன் ஸ்டார்ட் பண்ணலாம்? Which one we'll do, ma? Tomorrow, shall we start the new lesson or?
Okay, sir.
Which one? Do we solve the problems from this lesson? Or new lesson? Which one we have to start? நாளைக்கு என்னமா பண்ணலாம்? அதை முடிச்சிருச்சு. சாலிபிலிட்டி ப்ராடக்ட் சிம்பிளா ஒரு ரெண்டு ஸ்டேட்மெண்ட்ல முடிச்சிருவேன். ப்ராப்ளம் சால்வ் பண்ணலாமா நாளைக்கு?
ஓகே சார்.
நெக்ஸ்ட் லெசன் என்ன எடுத்தோம்?
நெக்ஸ்ட் லெசன் சார்.
ஹைட்ரோ கார்பன்ஸ் முடிச்சுமா முடிக்கலையா? Do we completed hydrocarbon? ஹைட்ரோகார்பன் முடிச்சிட்டோமா?
நோ சார்.
Okay. So next hydrocarbon or redox reaction. Which one we have to start?
Hydrocarbon, sir.
ஹைட்ரோகார்பன் சார். ஹைட்ரோகார்பன் சார்.
So, okay. So tomorrow, first half an hour, we will discuss about the problems in the equilibrium. Okay. Some of the problem we will discuss. Okay. Afterwards, we will start the hydrocarbon. சரியா?
ஓகே சார்.
Okay, sir.
இன்னைக்கு தாண்டா பேசுறீங்க.
தேங்க்யூ சார்.
So okay. So we will meet tomorrow.
Thank you, sir.
Mm-hmm.